Now, for gas phase reactions, activities are typically given in pressure, as we mentioned earlier. But sometimes you can have activities expressed in terms of concentration. So you need to be aware of this, okay? And what do we mean by concentration in the gas phase? If you recall your ideal gas law, PV equals nRT, we can rearrange this to say what? That P is equal to N over V times RT, right? So that means what's N over V? Moles per liter. So that's concentration. So I can write that as CRT. Okay? So if that's the case, then what is Kp? Let's look at a simple reaction. All right? Let's say you have A gas going to 2B gas. Okay? What is our Kp? Is equal to pressure of B squared divided by pressure of A, right? That's activities for a gas is pressure, correct? But what if I want to use concentration instead? What's pressure of B equal to? Concentration of B times RT, that's the pressure of B, right? So I can rewrite that and then square it. That's my numerator. What's my denominator going to be? Pressure of A would be concentration of A times RT. And this one I'm going to raise to the power 1. What is this 2 and 1? That's the coefficient of A and B in your balance equation. Right? Okay, let's do a little math review. If we have x to the n over x to the m, what's the answer? How can you simplify that? That's x to the n minus m, right? So like if you have x cubed over x squared, what do you get? X to the 3 minus 1, minus 2, which is x to the 1, right? So I can simplify this. I can say this is concentration of B over concentration of A times RT raised to the power 2 minus 1. Okay? So this gives me equal to, what is this concentration of, oh, this should be concentration of B squared. Sorry about that. So this is concentration of B squared over concentration of A. I'm just collecting all my RTs. Okay? So this thing right here, concentration of B squared over concentration of A squared, that's just Kc. Okay? So Kc times RT raised to the power 2 minus 1 is what we would call the change in the moles of gas when you carry out the reaction. Okay, so Kp will just be equal to Kc times RT raised to the power delta N gas. Okay, so what I call concentration of A here, and that's essentially this one right here. So that's moles of A over V, that's P sub A over RT.
We still keep the second power with CB over CA
Uh-huh.
RT when you put the 2 minus 1.
Okay, let me do this step by step. Let's go from here. Okay, so this is going to be CB squared times RT squared. Okay, and this denominator is going to be CA times RT. Okay, if you have x times y squared, that's the same thing as x squared, y squared. Okay, so that's why that 2 still stays with the c sub v. Okay, so now that's going to be k sub c. This thing is k sub c. And this thing right here would be RT raised to the power 2 minus 1. Okay? So, it's a good way to remember this is to say that pressure is equal to CRT, right? Concentration times RT, where C is N over V. So Kp would just be Kc times RT raised to the power delta N gas. because your numerators will be multiplied by RT to the whatever coefficients of the products are, and your denominator will be multiplied by RT raised to the power equal to the sum of the coefficients of your reactants, just for the gas phase, okay? So let's illustrate that with this clicker question. How is Kp related to Kc for the following reaction? A gas gives you 2B gas. 50-50 again. Half of you fell for the trick, I guess. No, maybe not. All right. Delta N gas for this is 2 moles of gas on the product side. How many moles of gas on the left side? 1. So 2 minus 1 is 1. So we say Kp is equal to Kc times RT raised to the power 1. Do you have any equation that shows that? It's Kp on the left, Kc on the right.
There's no right answer.
Yes, there is. Because what if I divide both sides by RT? Divide both sides by RT. What do you get? Kc is equal to, it's going to be equal to Kp over RT, right? So that's another way of writing it. So that's Kp over RT to the delta N gas. So that's going to be equal to Kp times RT to the negative 1. So which one's the correct answer? No? Correct answer is C. I guess more, not just half fell for the trick. It's the whole class. How about, let's try this one. A goes to B gas. What if K, suppose you found Kp to be 10, what would be Kc? What's the relationship again? Kp equals Kc times RT raised to the delta N. What's delta N gas here? 2 moles of gas in the product, 1 mole in the reactant. That's going to be 2 minus 1 is equal to 1 Kc RT to the 1. So if I want to solve for Kc, Kc would be Kp over RT, right? So what would it be? What's our Kp? 10.0. What's my R and what's my T? My T is 298 Kelvin, unless otherwise specified. Assume it's 298 Kelvin, okay? But it is given here as 298, so you're okay there. What's our case? What's our R? Since our pressure is given in atmospheres, your R would be 0.08206, okay, liter atmosphere per mole Kelvin, okay? But you really don't need to put the units there. Just keep in mind that since Kp is in terms of atmosphere, okay, because you really shouldn't be putting any units here, okay? So let's just do it that way. Okay. Now, if you are doing Kp in terms of bars, okay, which is the modern way of doing it, then you divide by 0.08314. That would be liter bar instead of liter atmosphere per mole Kelvin. Okay, but like I said, we're just going to stick with atmosphere since your book does that. So you use 0.08206. Okay. All right. How is Kp and Kc related in the following reaction? Calcium carbonate solid gives you calcium oxide solid plus CO2 gas. Let's see if you do better on this one. Okay, let's see. Popular answer is C. Why is C? What's delta N gas here? How many moles of gas do you have on the product side? 1. This is a solid, right? So that doesn't count. So 1 mole of gas on the product side. How many moles of gas do you have on the reactant side? None, because that's a solid. That doesn't count. So delta N gas is equal to 1. So we say that Kp equals Kc times RT. So what is Kc? Is Kp times RT to the negative 1. So correct answer is C.
I'll put that and do